Okay, for exercise C, at least 2 play in a sport team if fewer than 4 of the students sampled play in the sport team. So I'll write it here. So I have probability. What I try to find. Okay, so the key thing for the success in probability calculations will be you can express everything in mathematical representations instead of words. If you can change the words into math, then everything will be easy, because after you change it to what you want to find, you change that into math representation, and then there will be a formula that I can apply to that. So the formula are fixed. So only what is asking can be different. After you know what you're trying to find, then just keep using the formula and you finally find the answer. So it's quite easy after you do the first step. So this one is asking at least 2 play in the sport team. So x needs to be greater or equals to 2. Given that, if, or knowing that, or given that is all given question, like it's all conditional probabilities. Okay, given that fewer than 4 students sampled play in a team. So I will have a given condition. After I write that, you will automatically think about the conditional formula. Okay, it was just the intersection divided by the probability of x less than 4. So the intersection between greater than 2 and less than 4 will just have 2 and 3 in between. X equals 2, not probability 2. Prob x equals to 2 plus prob x equals to 3. And that thing will divide by prob x less than 4. Okay, so that is actually, you will directly write after the first step, because you will find the intersection between the 2, which is 2 and 3. And then the bottom will be 0, 1, 2, and 3. Okay, 0, 1, 2, and 3. So after that step, I can just use calculator to work on that. Where's my calculator? Here's the calculator. You have your calculator, that's a fraction. Again, I still can use 5e because it's 2 values, 2 and 3. The number of trials is 10. 0.6 to be success. It's the same, it's following yesterday's information. Okay, x is binomial distributed by 10 and 0.6. So it will be the same. And then I will have lower bound, which is 2, and upper bound, which is 3. Well, probability 2 plus probability 3. So it's 2 and 3. So I press OK. And it says arrow. Doesn't matter because I put that in a fraction. I just press OK again. And then I put the other part here. So I can directly drag up. So I can Control C to copy that and Control V to paste. And what I need to change is this one. I will change that to a 0. And I will change that to a 4. Because, not 4, it's 3. Because less than 4 is 0, 1, 2, and 3. So the lower bound is 0, upper bound is 3. So I will just have this one. Lower bound is 0, upper bound is 3. Okay, press enter, you have this probability. Let's just keep 2 decimals, 0.97. Okay, 0.97. Just 2 decimal places. So that's the basic understanding of, yep. Like method 1, I think it will be that, and then that will be just the answer mark. It's not going to be more than 2 marks. So no. Okay, so the thing is, never write calculator instructions on your paper, like the syntax thing. Never write on that, because there's like more than 2 calculators I know so far, like the school will use. Examiners not necessarily know what calculators you're using, and there's no point you write that and confuse them like what you're trying to talk about here. So just directly give the answer, because if they really want you to do hand approach, they will say show it, like, or by calculation, or like really like clear statement to say ask you to do it by hand. and you can't use calculator at all, or without like state. If it's a part 2 exam, you just use it. Like it doesn't matter how many marks is the question, but like say you must have steps. Like where is this answer coming from? For example, you need to set up the first equation and then directly equals to something. That's totally fine. Okay. Okay, next one. 14b. Okay, 14b. Okay, so 14b is talking about the shape of the graph. Okay, it's talking about the shape of the graph. So the graph expectation and variance of a binomial distribution. So we have 3 different type of graphs. Okay, we have 3 different type of graphs. Okay, I have like just attached 3 graphs on the book here. So this shape. Okay, so first, this is an example of when p equals to 0.2 and n equals to 20. So this is actually x binomially distributed by 20, 0.2. 20, 0.2. Okay, that's a distribution like that. And I want to sketch this graph. So how do we actually sketch this graph? I just calculate individual probabilities. Where x equals to 0, x equals to 1, x equals to 2, and I put the dot here. Okay, so it is not continuous. You can't just connect them like that. You can't do that because you can only have x equals to discrete value 0, 1, 2, 3, 4. Okay, you can't say I'm successful for 2.5 times. It doesn't make sense. So this shape, okay, let's have a look at this shape. The highest part is before the middle. Okay, before the middle is 10. So the highest value happens before the middle value. So this is called a positively skewed shape. Okay, this shape is called positively skewed shape. So like everything is like larger value happen before the middle. So it have a long tail, okay, have a long tail. So the tail here is like really long. So the greatest value is before the middle. And what kind of p-value can give you this shape? This is when p is in between 0 and 0.5. Okay, when p is in between 0 and 5. So this is called positively skewed. I would just say that is something when p equals to that. So the mode exists before the middle. Before what? Before n over 2. So the mode, the highest value, occurs before the middle of the number. Okay. Okay, occur before the middle. And then we have negatively skewed. This is just like the highest point occur after the middle. After the middle. So this p equals to 0.8. So you know that this p will be greater, not 0.8, greater than 0.5 and less than 1. So it will be in between 0.5 and 1. Okay, in between 0.5 and 1. So when you have a value greater than 0.5, and then that will have a negatively skewed. So the mode occurs after the middle, okay, after the n over 2. Okay, and then we have symmetrical shape, which is when p equals to 0.5. This is just purely p equals to 0.5. And you have symmetrical graph. Then the mode will be the middle. Okay, the mode will be the middle. Just exactly the middle. So for example, this one, what is the middle for 20? Okay, what's the middle for 20? Is 10 and this is the 10. Okay, this is the 10. There's 21 numbers. So when n equals to 20, you can have 0, 1, 2, 3, 4, 5 until 20. So there's 21 numbers. 10 on the left, 10 on the right, and then 10 is in the middle. Okay, 10 is in the middle. So 10 will be the mode. So it's just the middle. It's just the middle. So p is 0.5. You have a symmetrical shape of the graph. Okay, just have a look. When p is in between 0 to 0.5, you have positively skewed. When P equals to 0.5, you have symmetrical shape. And when P is greater than 0.5, you have negatively skewed. Okay, we have negative skewed. So that's just three shapes of the graph for binomial. Okay, it's only those three. It's only those three. So for binomial. Okay, and the next thing we're looking for is, what we know is 5 things we're talking about: expected values, variance, standard deviation, mode, and median. Okay, mode and median. So we're looking for that. In binomial distribution, we focus on the first 3. Okay, we focus on those 3. Expected value, variance, and standard deviation. We focus on those 3. We're not really talking about median and the mode, but I'll still let you know what to do with that. Okay, so I'll just let you know. You can see there's 3 new formulas here. Okay, there's 3 new formulas compared to what we learned before. But it doesn't matter. The previous formula can still be used in this case. So this is just a shortcut. This is a shortcut because binomial distribution is a special distribution and it follows some pattern. That is just a shortcut for us to find the expected value and variance. But we still can use the normal way of finding expected value and variance. So how we can do that? For example, we have x is binomially distributed by 4,0.4. Let's just do that. So what's the normal way we can do it? Is set up a table. Keep it back to a table. So x belongs to x. Have 0, 1, 2, 3, and 4. And I can calculate the probability by probably x equals to x. N is 4. 4x and 0.4 to the power of x and 0.6 to the power of n, 4 minus x. Okay, I can use that formula or say use calculator to find the probability in each box. Okay, I can have A, B, C, D, and E. So I can find the probability by substitute x equals to 0, 1, 2, 3, 4. Okay, so I can put back into a table. And how do we find expected value? We times vertically and add all of them up, right? We times 0 times A, 1 times B, 2 times C, 3 times D, 4 times C, and plus them. Okay, it's too much things to do. Okay, so it's too hard to do. If you do this example, after we figure that out, and we can see that value is exactly the same as n times p. Okay, it's exactly the same as n times p. Because this is a really logical thinking. I play something 10 times, and the successful rate for each time is 0.2. How many times you expect you can win? I play something 10 times, and the successful rate is 0.2. Then it's 10 times 0.2, which I will expect 2 times I can win that. So it's a really logical thinking. So I just want to say, those formulas still can work if I turn that into a table and still trying to calculate by the same way. Yes, it's still working. But there's an easy way you can use because it's a special, follow some pattern distribution. So n times p will be the expected value. So again, variance can be calculated by that as well because I can find x squared. I can use expected x squared, subtract expected x, then square it, and I can find the variance. But again, it's too hard to do, so you have np times 1 minus p. So it's n times the successful rate times the failure rate. Okay, so that's the variance. N times the successful rate times the failure rate. That gives you the variance. And standard deviation using the same way to do square root of the variance. Okay, square root of the variance. Okay, so that's the 3 formula you just need to remember. And for mode x, for mode of x, is either you can put that into the calculator to see all the values and find the maximum probability, or you can use it just list them out for each probability and see which one is the largest probability. But I never see a question in VCAT really asking that. They're not interested in that at all. Okay, but you know how to do it. Is the maximum probability value. So you can find the probability for individual thing and you can find where is the maximum. Okay, where is the maximum? Median. Well, median I think is a little bit more important compared to the mode. So median is just the 0.5. Okay, median is the 0.5. So for example, I just use this as an example. So I want to find the median for this distribution. What I should do? I want to find the median for distribution. Okay, first of all, tell me, is that a positive skewed or negatively skewed shape? Is that a positively skewed or negatively skewed shape? Negatively skewed. So you will have something like that. So more things is behind. Okay, more things behind. So I would guess my median will be maybe slightly after the middle 5. Okay, like because you want 50%, right? You want 50%. So you want that part become 50%. So I think it's not exactly, here's 0, here's 10. I don't think that's 5. I think 5 is somewhere in the front. So I'll guess the value. I'll try 5. Let's try 5 first. Menu 5E. So I have 10 trials and I have 0.6. And I have lower bound, just stay at 0 because we want to see start from 0 until where you have 0.5. So let's try 5. It's only 3 point something. As I said, it should be much far than 5. It's not like before 5. So I just copy the same thing and change that number to 6. Again, at 6, what happened? It become over 0.5. Okay, the previous value is lower than 0.5. So what is the median? No, it's not the middle. If it's 0.5 and 0.5, then it's the middle. If it is exactly 0.5, then that's the middle. That's not exactly 0.5. Remember that if we have a table, like that, 0.1, like at 1, 2, 3, 4, 5, let's say that. 0.1, 0.2, 0.4, 0.1, 0.2. Is that 0.1? 3, 7, yep. So what's the median for this one? 3. Okay, 0.1 plus 0.2 is less than 0.5. And plus a 0.4, then over than that. Then 3 will be the median. So then come back to this case, what will be the median? When it's to 5, it's still not reach 0.5. Then we add to 6, then it's over than that. So 6, okay, 6 will be the median. So it's same as you put all the values in the table and you try to add them. When you add to 5, then still not. You add another 1. Yes, that's 0.6 already. So 6 will be the median. Okay, 6 will be the median. So you just need to try. You need to try the previous value less than 0.5 and the value after will be greater than 0.5. And then after 0.5 one will be the median. Okay, will be the median. So what the notes talking about here is you just put n value, p value, and 0 here, and you try a value. You try a value when it's less than 0.5. Then you try a plus 1. It is greater than 0.5. Then the median will exist at a plus 1. So you try a value first is less than 0.5, and you try the next large number is greater than 0.5. Then the a plus 1 will be the median. Okay, if you just have, sorry, I don't really need to have that. Can you just cross out the second part here? I don't want that, and the and as well. So if NP 0 to A just give you 0.5. Okay, so you have 0, 1, 2, dot, dot, dot until A, and then A plus 1, A plus 2, dot, dot, dot until N. So if those probability just give you 0.5, which means those probability just give you 0.5 as well. Therefore, the median will be in the middle of that, and that's a plus a half. Okay, that's a plus a half. So just find the middle two numbers and divide them by 2. Add them and divide them by 2. And that will be the median. Again, it's not really asking median at all. Like sometimes maybe ask you that, but like very unlikely. Okay, very unlikely. But I still need to teach you how to do this type. Alright, let's have a look at example 2. The probability of rain in Ballarat on any day in the month of June is 0.62. Okay, if X represents the number of rainy days in Ballarat during June, find. Okay, so after I read this, can you recognize that's a binomial distribution? Can you see that's a binomial distribution? Well, what is binomial distribution? It needs to be identical trials. Okay, every day is identical trials. Probability needs to be the same. Yes, every day probability is the same. Not influencing on each other. Well, yes, it's not influencing on each other. Well, maybe it just needs to add one sentence like it's not affecting each other. Whether today's rain is not affecting tomorrow. So it is a binomial distribution. So because I repeat something many times and the probability are the same, all the conditions are the same. So it is a binomial distribution and already give you that X is the random variable. So first, X is binomially distributed. 0.62 is definitely the successful read because it's a rainy day. What's the number of trials here? What's N? 30? June is 30 days, okay, so it's 30. So it's 30, 0.62. Okay, so the expected number of rainy days in June. So A is asking you the expected X. Expected rainy days, so it's expected X. So it's 30 times 6.2. And that's 18.6, I believe. Yep. 0.62 and then times is 18.6. Yeah. I directly moved the 30 0 to that side and it's 18.6. Also it's correct. Okay, 18.6 is the expected value. And I'm looking for the variance in the number of rainy days. Okay, variance. So if you're looking for the variance, VAR of X, that is NP bracket 1 minus P. So you will have like NP, you already worked that out, is 18.6 times 1 minus P, that is 0.38. So NP is that, 1 minus P is that. So what I will have is 18.6 times 0.38. 7.068. That's the variance. Just let you know, there's one type of question is asking that. Say if X, like given you, like that's another question, okay? Given you X is binomially distributed by N, P, and give you expected X, that is, let's say 10. And give you a good number, maybe, let's just say 10. And give you the variance is 10. Let me have a think. I need a good value. Just say 9. The variance is a 9. Oh, it's too large. 4. Let's say 4. And then it is asking you, just that's all the information you have. So find N and P. That's a really easy question. And it's like 2-mark question in exam. I think it's VCA exam. That's it. That's all the information you have. Okay, quickly tell me what is the value. So tell you x is binomially distributed by n, p. You don't know the value. But give you expected x is 10. Variance is 4. And ask you to find n and p. Like the special thing about the expected value is np here. And that's np1 minus p here. So if you use your variance to divide by your expected value, if you use your variance of x divide by expected x, you will have 1 minus p. Okay, you will have 1 minus p. Because np divided by np is 1, and then you're left with 1 minus p. So variance divided by 10 is 0.4. Then p is 0.6. Okay, 1 minus p is 0.4, p is 0.6. And then n equals to 10 divided by 0.6. And it's 100 divided by 6, 50 divided by 3. I don't care what is it. It's not a good number, so I can't make a good number. So, but the answer will be this. Okay, like when they give you the question, it will give you a whole number. It shouldn't solve out like as a decimal. It should be an exact like integer numbers here. But like I can't really think about a good number. Yep. 1 minus p is 4 divided by 10. Variance divided by expected value. That's 0.4. Okay, that's 4 divided by, maybe right here. That's 4 divided by 10. That gives you 1 minus p, and therefore p is 0.6. Okay, and n will be that divided by that. So this question seems like really easy, but if you can't really think about you trying to divide them, then you can't do it. Okay, it's very little information given here. So that's some question might be asked in part 1 exam, so you need to pay attention to that. Okay, come back to this. You have variance now, and I want A, B, C. C is ask you the standard deviation. So standard deviation x equals to sigma equals to square root 7.068. Oh. Okay, so let's go to decimals 2.66. Yes, 2.66. Okay, it's interesting for the last one. You must know how to do this type, and it's helpful for last chapter. So last chapter we'll do this type of question as well. So get familiar now. Have a think about this expression. Probability mu minus 2 sigma and mu plus 2 sigma. That looks familiar. Have you ever seen it somewhere else? Yes? No? You see it? Just this week. It looks familiar, right? Well, let's have a look. Where is it? Okay, I just opened this notes for you. Can you find it? Can you find it somewhere? He's not in this one. He's in the previous one.
Oh, give me a second.
0.95, okay? So what it's talking about is when your x is in between the mu from 2 standard deviation to the left and the right. If I'm talking about the probability for those set of values, then you will have a probability approximately 95%. Like it's more like it's getting more and more accurate when you have continuous distribution and when there's more data you're talking about. Like if we talk about 10 trials and we talk about 70 trials, the 71 will get closer to 0.95, okay, even closer to 0.95. So what we will have in this question is, you can't just answer 0.95, okay? So you can't do that. So what you can do is calculate that. So calculate that. So let's have a think about D. So what's mu minus 2 standard deviation? Let's calculate mu minus 2 standard deviation. That equals to, okay, 18.6 minus 2 times that. Okay, mu minus 2 standard deviation. That's a value 13.28. 13.28. And have a think about what's mu plus 2 standard deviation. Uh, 23.92. Okay, 23.92. I just calculate the value because I know mu, I know sigma, so I can calculate the values for those two parts. So let's write this. Is that equals? Yeah, it's equals as well. Okay, let's have a think about that. What is x? What is x? Do you remember what we're trying to looking for? A number of rainy days. And it will expect that to be an integer number, right? It can only be whole numbers. So what are the whole numbers in between that? So, okay, what's the limit? What's the upper bound and lower bound? I heard 23, 24, and 22. Which one? Okay, it's actually you need to correct it into the integers because the x is talking about the number of rainy days and you're not talking about like 13.28 days. You're talking about 14 days. It must it's not really thinking about going up, like rounding up or rounding down. It must be like the number in between those two decimal numbers. So you're not really thinking about 13 there. You think about 14 because you need to get greater than that. So the next integer will be 14. Then I can calculate that amount because you know x is binomially distributed by 30,0.62. So I will have my calculator, menu 55E, have 30, 0.62, lower bound is 14, upper bound is 23. Is that 23? Yeah. Yep. And I press OK. Let's see the value. It's about 0.942. Okay? Is approximately 0.942 and it's quite close to 0.95. Okay, 1% difference. So which means what we talked about before is quite accurate. Yeah, it's quite accurate. All right, so that's this exercise. Okay, that's this exercise. Okay, last one. Oh, I think I can finish it today. That's good. Last one is finding the sample size. Well, only this page is new thing. Okay, only those 3 pages are the new thing. Finding sample size, you learned that last year as well. Okay, last year 11 book, you have this exercise as well. So finding the sample size. This is she. Her, no, her. Her probability, okay. Her probability of hitting the target is 0.6. What is the minimum number of shoes needed for the probability of Isabel that the target exactly 5 times to be more than 25%? Okay, this is a really long sentence. It's just one sentence. Let's understand what it's actually talking about. So, can you tell me anything you know after you read this? It's a binomial because every shoe will be the same. Anything else? And P equals to 0.6. Okay, let's first set up a random variable. Let x be the number of times Isabel hits the target. Okay, so let x be that. Then you said x is binomially distributed. By what? You said P is 0.6. What is n? We don't know. A is n. Okay, we don't know. A is n. So it's n comma 0.6. So what else I can write after this? Okay, probability x equals to 5. So probability x equals to 5. Okay, that equals to what? Is that equals to or greater than 0.25 or 25%? Okay, or 25%. So we just put things like piece by piece all together. Okay, so that's everything the question is talking about, and I changed that to math representations. So let's have a think. By using binomial formula, again, this chapter, this exercise, we must use the binomial formula. Okay, this is very important now in this exercise. So I think this formula is only using for working on those questions. I need to expand that. Because I don't know the n value, I can't directly put that into the calculator. The calculator won't find any question for me because there's no n values. So how I can expand x equals to 5? Yeah, n choose 5 and 0.6 to the power 5 and 0.4 to n minus 5. And that needs to be greater than 0.5, 2.5. Okay, before we solve for this, I just want to ask you something. Do you think A is larger the better or A is smaller the better? Like N should be larger to get a higher rate or N should be smaller to get a higher rate? Well, I want to shoot exactly 5 times. I want this probability to be greater than 25. Well, obviously I can't shoot less than 5 times. This number must be greater than 5. Well, if I have 5 times, the probability of all success is very hard. Okay, I just shoot 5 times, and I want them all shooting target is very hard. So can you give me can you really think about do you think n should be larger or smaller? Larger. How about n equals to 100? Do you think there will be a larger probability or smaller probability? When n equals to 100, do you think that will have a relatively large or small probability? if it's 100, okay, if it's 100, it's 100 choose 5, which is fine. And it's 0.6 to the power 5, which is fine. But 0.4 to the power of 95, that's a really small number. Okay, that's a really small number. So you will have a really small number after you do 100 times. So you need a balance. Why we need a balance? What's the meaning of this expression is I want exactly 5 times. I don't want more, I don't want less. I just want this much. Have a think, if you just do 2 little times, it definitely the probability will be lower. Okay, so if you only do 6 times, I want 4 shooting the target, it's hard to get. That's quite make sense. But like say if I do it 100 times, have a think about how poorly you can play and you only shoot 5 times. Like it's almost impossible. And plus your target rate is 0.6. Okay, it's quite high. It's not low at all. So how poorly or how bad luck you will play the game and 100 times you just shoot 5 times. It's impossible. Well, it's possible you shoot like 60 times or like 65 times. It's like you get a higher probability. But only 5, impossible. It's just 0.00 something like you will get. So you need a balance between 2 boundaries. Okay, one is too little, one is too much. Your answer will be in between that. I hope you can understand that. So it can't be too little, it can't be too much. Or like if this number is greater than 5, if x is greater than 5, say what's the probability I can get more than 5 times? Then the larger the better. Okay, the larger the better, because you just need 5 above, and it's alright. Like I can have 5, 6, 7, 8. It's all good. 100 is satisfied as well. But this one is too crucial. It's only asking you exactly 5. That's why there needs to be a balance. The probability will increase first, and then when it reaches a point, then it will decline. Okay, so that's what going to look like when you increase the n value. So let's solve for this. Okay, the thing is, I can solve this by calculator. That's the good news. But you need to remember one thing. The calculator cannot solve inequality. Okay, the calculator cannot solve inequality. Like, I didn't say like a simple inequality is fine. But like this complex inequality, you can't solve. So what we need to solve is equal. Okay, what we need to solve is equal. So what we will have is like change that to an equal sign. Okay, I'll change that to, well, don't change it on yours, like do a next line, like write the next line. So what you want to solve is actually that. And what you need to press is menu 3, 1. Okay, solve normally. Menu 5 and combination number 3. Menu 5, 3. Menu 5, 3, and we have NCR. That's n choosing 5. So x comma 5 times 0.6 to the power of 5 times 0.4 to the power of x minus 5. Alright, that needs to be equals to 0.25. How many values do you expect you will have? How many answers do you expect you will have? Have a guess. As what I said before, like the not too much, not too little, you have 2. Okay, you have 2. So let's just press comma x, forgot the comma x. Okay, I have 2 values. This value is you can't get below that amount, and the next value is you can't get exceed that amount. Does that make sense? It can't be too much, it can't be too little, so it will be a balance in between those 2 numbers. So it's only the numbers in between that is possible. So x equals to 6.8 or x equals to 9.02. Okay, so what x can be? What x can be? what you solve from calculator. So what this x can be to make this equation satisfied? X needs to be integer numbers, okay? Integers. What's the number in between 6.79 to 9.02? 7, 8, and 9. So even though it's an inequality, it's only those 3x can give you a probability larger than 25%. Okay, it can't get above 9.02 because, as I explained, you can't play 100 times and you expect you have 25 of the chance get like exactly 5 times. There's no way to achieve that. So 9.2 is your largest number to have it just equals to 25%. So your value needs to be in between those two amount of times. And question is asking the minimum number. So x equals to 7 is the minimum. Again, you are not thinking about rounding up or rounding down. You find the exact integers in between those two values. Okay, it's the number in between those two values. Even though that's a 6.01, you still have 7 as your next number. Okay, next possible number. So it will be 7. So that's the first type of solving binomial distribution to find the n values when it is exactly equals to something. When it's exactly equals to something. Let's have a look at the next one. The probability of winning a game of chance is 0.25. What is the least number of games that must be played to ensure that the probability of winning at least twice is more than 0.9? So again, I'll let y be the number of times winning. Okay, I just found the winning number of times. So y will be normally distributed by a number I don't know, which is lowercase n, and the successful rate is just 0.5. Okay, that's different compared to the previous question. Okay, be careful with that. So I want the probability at least twice. So I want probability y greater or equals to 2. I want this probability to be more than 0.9. Do you think the larger the n the better or the lower the n the better? Larger. Okay, this one is just purely larger. Because it's not equals to something, it's just greater than that. I just want a higher probability. I just want to do something successful for more times. Like greater than 5 is fine. I'm happy about it. Greater than 2, I'm happy about that. So anything greater than 2 is alright. So the larger the n, the better. Alright. The next thing is what y can take. So yep. Y is normally distributed. That's the n. It's normally distributed. Sorry, wrong. Binomial. What I'm right? It's binomial. I'm not normal. Yeah, binomial distributed. No, it's not normal. Yeah, I just go something 2 chapters next. Like the next 2 chapters is normal. Okay, so you know what you're going to learn next. So what y can take? What y can be? Do you know what y can be? Y can be 2, can be 3. What else? Until n. Okay, so you don't know what is it. You don't know what is n. You don't know how many numbers are there in between. So let's think about what n cannot be. 0, 1. Okay, 0 and 1, this cannot be. Well, it doesn't matter what n equals to 2. You always have 0 in the front. You always have 1 in the front. So you always can't take 0 and 1. So instead of thinking about the greater case, you will think about 1 minus probability y equals to 0 and 1 minus y equals to 1. I want this rate to be greater than 0.9. So greater than 2 is the same as 1 minus 0 minus 1. Okay, minus 0 minus 1. Okay, let's expand that because like you can't directly use calculator to solve, so I will expand. Okay, I will expand somewhere. Just use here. 1 minus n select 0 is 0.25. Let's say just a quarter. A quarter to the power of 0 and 3 quarters to the power of n. And minus n select 1. A quarter to the power of 1 and 3 quarters to the power of n minus 1. And I want that to be greater than 0.9. Let's just do this. Let's do this plus this is less than 0.1. How about that? It's just easier. Okay. One subtract that subtract needs to be greater than 0.9. Then this plus this must be less than 0.1 to make it greater than 0.9. Okay, so that's less than 0.1. Subtract, you add them. Okay, now is the exciting part. What's the first expression n selecting 0? 1. What's a quarter to the power of 0? 1. What's that? 1 select n. N. Okay, I have simplified a lot. I've simplified that a lot. So I will have 3 quarters to the power of n plus n over 4 times 3 quarters to the power of n minus 1. That needs to be less than 0.1. Okay, less than 0.1. And I just need to solve for it by a calculator. Okay, I just need to solve it by calculator. Again, it can't solve by inequality. So I will do equations. So we have 0.75 to the power of x plus division x over 4 times 0.75 to the power of x minus 1. This needs to be that needs to be equals to 0.1. Okay, equals to 0.1 and comma x. Comma x. We can have a think about this expression. I just copy down whatever we write on the paper, and instead of inequality, we put the equal sign there, and we're trying to solve for it. And you will have a negative value, which is like you don't really need to think about it, and you only think about the positive value, which is 14.04. Okay, 14.04. Do I have the correct expression? To the power of x, x over 4, 0.7. Okay, so as we said, the larger the better. So n should be greater than 14.042. Okay, so what's the minimum number of n? 15. Minimum of n is 15. You always going up. Okay, you always going up by 1 unit. So it's 15. Okay, have a think about example 5. Think about example 5. The chance of ticket winning of 5,000 prize is that probability. Okay, I don't care about how much I can win. I can't win anyway. Just don't think about that. That's a number which is useless. So of winning is 1 on what's that? That's 10 to the power 5. I think 1, 2, 3, 4, 5, 5, 0. Okay, it's 1 over 10 to the power 5. And what it's asking is find the number of tickets that need to be purchased to ensure at least 50% sure of winning. Okay, at least 50% sure of winning. This question is not very explicit because it's not really like the previous two questions tell you what's the exact numbers. Okay, the first one asking is exactly 5. The second one says like larger than or equal or greater than 2. But this one doesn't really say a value that you must like greater or less than. Have a think about you buy. Anyone ever buy that? I don't think you can. Yeah, you can say yes, and I can just record that down. Okay, well, you know how it works, right? You know how it works. How like you can buy more than one ticket. And there can be more than one ticket of winning. Okay, not only one person can win. You can have like multiple persons like win that. So if they have the same number or same ticket or something like that, they can still win together. So what's like you have like say for example 100 tickets. What is the case like you actually win? So under what like how you can say you win something? Like say you actually buy 100 tickets, and then in which case you said you win the 5,000. How you can win? How you can win? You have 100 tickets. How you can win? First, I'll just say if none of them are the same number or same condition as that, can you win? No. Okay. If one ticket get the same number, can you win the money? Yes. How about if I have 2 tickets actually having the same number? Can you win? Yeah, you just win 2 tickets. Okay? If you have 3, you still can't win. Okay? So it's only when you have nothing, there's no ticket satisfied, then you are not winning. So it's asking you say, the probability of winning is actually saying at least one ticket works. Okay, at least one ticket works. Well, it can have more than one ticket works. It can't just say one working. It can be 1 working, 2 working. Very, 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 very unlikely. Say like all of them working, but there's still a chance. Okay, it can work. It's still a chance it can work. So let's say let n be the number of tickets winning. So how many tickets you can actually have the same number or same conditions as it requires. So n will be a binomial distribution. And known value of n and probability of 1 on 10 to the power 5. Okay, let me quickly finish it. This probability of n greater or equals to 1 needs to be larger than or equals to 50%. So 1 minus probability n equals to 0 needs to be larger than 50%. Probability n equals to 0 needs to be less than 50%. Equals to 0, which is n select 0. 1 on 10 to the power 5, 0. 1 minus 1 on 10 to the power 5 to the power of n less than or equals to 0.5. Which that's 1, that's 1. So you just solve for that equals to 0.5. Okay, you just have that just equals to 0.5. to the power of x that equals to 0.5, comma x. 69314.37 something. So n equals to that. Okay, one larger, one value larger.